Hey guys, today we're going to work on practice number 7, problem number 2 of stoichiometry, and this is a mass-to-mass problem. So if we go ahead and read this one is a little on the tricky side. So it says silver sulfide is the common tarnish on silver objects. What is the weight of silver sulfide produced when you combine an excess amount of silver with hydrogen sulfide and an excess amount of oxygen? Now again, it's going to produce silver sulfide and water as a byproduct. So we go ahead and we start off. We got to first, what we have to do is we have to go ahead and write out our skeleton equation. So we're going to start off with what we have. So we have an excess amount of silver. So we're going to put down Ag. Now, where did we get Ag? Well, if we look at the periodic table and we scroll up through this, we can see that silver is right here, and it is Ag. So let's go back to the problem. And with that, we're going to have hydrogen sulfide. Now I gave you hydrogen sulfide. There it is right there. So we're going to put that in there. So we're going to add to that hydrogen sulfide. And we're going to have an excess amount of oxygen. So we're going to have oxygen. Now remember, if there's an element by itself, we have to ask, is it diatomic? So we'll look at silver. Is silver diatomic? No, silver is not one of the diatomic. What about oxygen? Well, let's go to the periodic table again. Oxygen is one of these 7 that are right here. So yes, it is diatomic. So we're going to make it diatomic. Now that is going to react, and it's going to create silver sulfide. Okay, now silver sulfide, if I go ahead and put and I tab over and put the charges here, silver is a +2, and sulfide, okay, excuse me, silver is a +1, and sulfide is a -2. So they don't match, so we're going to crisscross again. So we're going to put the 2 here with silver and 1 with the sulfide. So it's going to be Ag subscript 2, and then a capital S for sulfide. And again, it's also going to produce water, plus H2O. So there is our skeleton equation. The only one that we really had to worry about was silver sulfide. And if we want to double check the number for silver, silver is right here. Again, it's right there. This is B1. But if we go down to page 12, we can see again where we're at as far as what is the atomic number, because silver is one of those exceptions. So again, I like to look at that. There's silver. It's a +1, and sulfur is a -2. So that's one of those things that we can look at as we go through. We can see what it is. So let's go ahead and go back so we know exactly what that is. So now we're going to go ahead and balance these. So one of the ways that we're going to balance them is we're going to put the same number on each side. So we're going to have Ag on this side over here. We start off, we only have 1. And we'll get over to the other side. On this side, we have 2. Now we have hydrogen. On this side, we have 2. And on this side, we have 2. We go down to sulfur. Sulfur on this side, we have 1. And on this side, we have 1. And then on this side, we're going to have oxygen for our next number. And we have 2 on this side. And we go to this side, we only have 1. Now, there's all of our elements. We have 4 on each side, 4 capital letters, 1, 2, 3, 4, 1, 2, 3, 4. So they're there. Now, again, a lot of times we might want to just start off with oxygen. That's this one right here. But I don't really want to start off with oxygen. Okay, so what are we going to start off with? We're going to start off with with oxygen. Actually, that's what we have to start off with. Normally, we wouldn't start off with oxygen, but we're going to start off with oxygen. Or we can start off with silver. It doesn't really matter. Okay. So we're going to go ahead and look at what we have. I just want to double check. So hydrogen is good. I have 2 on this side, and I have 2 on this side. So we're going to get our silver. So we're going to put in here. We're going to put a 2 there, and that means that changes that to a 2. Okay. Sulfur are good. Hydrogen, I have 2 there and only 1 there. So that looks like we're balanced. So 2, 2, 2, 2, 2. No, oxygen's still not balanced. Oh, we got to change oxygen. So how do I get 2? So I got to change this to a 2. Okay, that changes this over here to a 2, but it also changes my hydrogen to a 4. Okay, so we're going to go ahead and get rid of those right there and get rid of this one here. Okay, so now I got to make hydrogen on this side 4, so we're going to go to our front one in front, and we're going to put a 2 right there because 2 times 2 is 4. That changes that to a 4. It also changes my sulfur to a 2. We'll go ahead and get rid of this. And this one. And then we're going to go ahead and look on this side. We have sulfur, I have to have 2, so I'm going to put a 2 right here. So that 2, that changes this from a sulfur to a 2. We'll get rid of this one. But it changes my gold to 4. Okay, so that means we have to go to the other side and change this to a 4. So we're going to just take that and change that to a 4. Okay, and then it changes down here to a 4. And now we're balanced. So our molar ratio is 4 to 2 to 1 to 2 to 2. And what is nice is, let's just go ahead and highlight those. Okay, in green, so we have them. Even though we have 1 there, we're going to make sure that we have it. Okay, and then this 2 will be highlighted. Okay. Now, if I don't have any space up here or somewhere else to put the molar ratio, go ahead and leave it just like that, but I want you to highlight that. Okay. I also want you to show your work. If you don't show your work and you make a mistake up here, that means you lose all the points for balancing the equation. If you show your work, I may give you partial credit for some of these ones that are correct. Now we're going to go ahead and do the stoichiometry, but in order to do the stoichiometry, we have to do the molar masses. So I'm going to go ahead and look at what do we have. We have this much of hydrogen sulfide, so that's one that we're going to look at. So I'm just going to copy this one right here. Copy, and we're going to place that one right there. And then we have to go ahead and what are we looking for? What else are we looking for? We're looking for what are the ways silver sulfide. So we're going to take silver sulfide. We're going to copy that one, and we're going to place that one right over here. Okay. And so now what I'm going to do is I'm going to go ahead and put down what we have of each one. So we have hydrogen, which we have 2 of them. We're going to multiply that by the molar mass of hydrogen. If I look at hydrogen back at the periodic table, there it is. The molar mass is 1. So we'll go back to it. So 1 times 1, or 2, excuse me, that should be a 2 times 1 equals 2. Okay, I'm going to go down here to the next one. And we have sulfur. And in sulfur, we have 1 times the molar mass of sulfur, which if I go to our periodic table, we'll see sulfur's right here. That's going to be 32. So we'll go back to our problem, and we're going to put in 32. Let me just make sure I have this right all together. And that's going to equal 32. And so my total will be, if I'm going to add those up, it's going to be 34 grams. And again, this is a final answer for something, so we're going to make sure that we highlight that one in our green. Okay, so we have all of these here. Let's see how we got them. Okay, so let's go over to the silver. We have Ag. We have 2 of them. We're going to multiply that by the molar mass. The molar mass, according to the periodic table, is 108. So we're going to go back to our thing, and so 2 times 108 equals, and I'm going to just do that in my head, it's going to be 216. Okay, And the next one that we have is going to be our sulfur. So we actually can just go ahead and copy this. That's there. We're going to copy. We're going to bring it over here. And we're going to paste it. As much as that is possible, I would say. Okay. Okay. So we add these together. And when we add those together, the total is going to be 8 here. Plus that's 4, so 248. 248 grams. And remember, that's grams per 1 mole. Same thing over here. This is grams per 1 mole. And this is going to be, again, of silver sulfide, and this one is of hydrogen sulfide. So let's go ahead and go down to stoichiometry. The first rule for stoichiometry is we're going to start with the number that's in the problem. So let's go back and look at the problem. The problem says we have 1.23 grams of hydrogen sulfide. So that's what we're going to start with, is 1.23 grams of hydrogen sulfide. So I'm just going to go ahead and copy this. Paste that. And again, I like to just go ahead and make sure that it's all the same size. So we're going to make it all 12. Then we're going to multiply it. And I like to do the bottom first. We're going to do the bottom by going ahead and tapping over, and we're going to have grams of hydrogen sulfide. Well, what's associated with grams of hydrogen sulfide? That's the molar mass. So we're going to put this number right here down here. So we're going to put in 34 grams of hydrogen sulfide. Now that's going to equal how many moles? Well, we know that it equals 1 mole of hydrogen sulfide. Okay, so now we have that. Now we're just going to go ahead and add our times. Okay, and we'll underline this so we know what we're looking at. So we have grams, I get rid of that. Now we have moles. Now I have moles of sulfide. Now this center one here, remember, that's where we're going to use our molar ratio. So we're going to put the number of moles of hydrogen sulfide on bottom. Okay, now where are we going to get this number right here? Well, we're going to get this number from the balanced chemical equation. So let's go back up, find hydrogen sulfide in there. There it is. And so this number is going to be 2. So we're going to put a 2 there. Then at the top, we're looking for, right over here, silver sulfide. So let's go up to the top, find silver sulfide 2. So 2 moles. It's going to equal 2 moles of silver sulfide. We'll copy that and paste that down. Now that we have it in moles, we can convert it back to grams. So if I have moles up here, I got to put moles down here. And that's going to be 1 mole at the bottom. We can see that of silver sulfide. And at the top, we're going to put this number in here. So we're going to put in 248 grams of silver sulfide. And that's going to equal. So now we went from grams of hydrogen sulfide to grams of silver sulfide. We're just going to go ahead and underline this one here. And we'll underline this one here also. And now we can get rid of what units can cancel out. So I have grams of hydrogen sulfide right here. So we're going to get rid of that. And I have the same on bottom, grams of hydrogen sulfide. We'll get rid of that one. I have moles of hydrogen sulfide here and moles of hydrogen sulfide right there, so I can get rid of both of those. I have moles of silver sulfide here and moles of silver sulfide down here, so I can get rid of both of those. Okay, so now look at, I have left grams of silver sulfide, and if I look up here in the question, it's asking for what is the weight of silver sulfide, so that's good for us to know. So we're going to put grams of silver sulfide, okay, and all we have to do is get out the calculator. So let's go to the calculator. Remember, we're going to take this number, multiply by the top, divide by the bottom, multiply by the top, divide by the bottom, multiply by the top, divide by the bottom. So when I go ahead and put it in here, we're going to take 1.23, and I really don't have to multiply by 1, so we're not going to. We're just going to divide by 34. Okay, so we're going to divide by 34. And then since I have 2 over top of 2, I don't have to do that one either. So then we're just, the only other one we're going to do is this one right here. Because to be honest, I can get rid of this 2 and this 2 because one's on top and one's on bottom. So let's go ahead and go back over to this. I have 123 divided by 34, and then we're going to multiply it by 248. So we're going to go times 248 equals, and that's going to equal 8.9717. I don't need to go any further than that because I got to look at the problem and say I need it in 3 significant figures. So I like to write down here 3 sig figs. Okay, and highlight that in a little bit different color. And then we go over to our 3 right here, and right there is where we're going to do our rounding. So we're going to put a special characteristic there. And at that number right there, it looks like we're going to round down. Okay, so we're just going to drop that off. So our answer is just going to be everything after this right here. So we're going to have that's going to be grams of silver sulfide. And we'll just go ahead and make sure that we have that highlighted. So there's our answer right there as far as that. It's rounded to the correct number of significant figures. We have our stuff here, but now, again, I like to make sure that we know that we're talking about that. So we're going to look at all those numbers. That's good. So now we're going to go ahead here and do our percent yield. So what is our percent yield? Well, our percent yield, I don't know, a percent yield equals our actual yield, and we're going to take that and we're going to divide it by our theoretical yield. Okay, we're just going to go ahead and underline that. Then we're going to multiply that by 100%, and we're going to get our answer. So what we're going to do is we're going to go ahead and do that. So our percent yield equals our actual yield, which is this number right here, 4.97 grams is actually produced. So that's what we're going to put on top, 4.97 grams. And then on bottom, we're going to put down our theoretical yield, which is this number right here that we just calculated out. So it's going to be 8.97 grams. Okay, and we're going to take away the boldness on that, and we're going to go ahead and underline that, and then we're going to multiply that by 100, and that's going to give us our answer. So let's go ahead and go back to our calculator. Okay, and we're going to put 4.97 divide by 8.97 multiply by 100, and that's going to give us 55.4. So we're going to put in here 55.4069. Now it says we need to round to one place after the decimal. So we're going to go right here's that one place after the decimal. That looks like we're going to round down. So what we're going to do is we're going to insert a character. Again, I like to go ahead and choose an arrow. Now, if you want, you can even make that arrow a different color, which is nice to see. And so we round down, so we drop that off. Okay, and we know that that's going to be our percent of silver sulfide, which is going to be Ag2S. Okay, so we're just going to come down here and put in our 55.4% of Ag2S. Again, we'll get rid of that. We'll make it look like we have. So there's our final answer. So we have 55.4% yield. Not real good in this reaction, but that's what we got. Hey, as always, go Mohawks. Nelson out.